Hey, algebra students. In this video, we are going to be talking about direct variation, and we're going to start by doing this exploration over here on the left. So, to make lemonade, when life gives you lemons, to make one pitcher, 5 lemons are used. We need to complete the table to show how many lemons are needed to make each number of pitchers. Well, this is pretty easy, right? To make 2 pitchers of lemonade, we're obviously going to need 10 lemons, okay? And then let's see, what's the ratio of pitchers to lemons? Well, let's see, this is going to be 10 over 2. 10 over 2 equals 5. I'm just going to take these two and copy them down. To make 3 pitchers, how many lemons do I need? Well, I'm going to need 15 lemons for 3 pitchers. That just makes intuitive sense. 15 over 3 equals 5. Let's keep going. To make 4 pitchers, I'm going to need 20 lemons. And I'll bet you figured out the pattern by now. Let's see. So 20 over 4 equals 5. And let's do one more. To make 5 pitchers, I'm going to need 25 lemons. And 25 over 5 equals 5. Okay, so notice what's happening. My ratio of lemons, which is my y value, to pitchers, which is my x value, is remaining constant. The ratio of x to y remains constant. Can we write a function or rule for determining the number of lemons needed if I'm using x and y? Well, we sure can. This was just, let's see, how would we do this? Well, how did we figure this out every time? We were just doing y equals whatever the constant was, 5, because it's 5 lemons per pitcher, times x times 5 times the number of pitchers gives us the number of lemons that we need. That's our function that we would write for this. Okay, and then how does the coefficient of x in the function compare to the ratio of lemons per pitcher? It's the same. This ratio here is the number that's multiplying x, and it always is the same. Now, to graph the function, all I would need to do is, if I go to a graphing calculator, y equals 5x, really easy to do this on paper too, because you just plug in a bunch of test values, 0, 1, 2, 3, 4. You could even just plug in what was in our table, okay? And you'd see that you get a graph that looks like this. I'm trying to zoom in here. Notice it passes through the origin, and it's just a simple linear graph, okay? Notice that all of these points are on this graph, including 5, 25, 4, 20, 3, 15, 2, 10, and 1, 5. Also 0, 0. If I make 0 pitchers of lemonade, I'm going to need 0 lemons. All right, and that is direct variation. Now, what exactly is direct variation? When an equation is one variable that is equal to a constant times another, 5x, y equals 5x. It's direct variation. The equation simply is y equals k times x, where k can't be 0, and it's called the constant of variation. K, by the way, can be negative, okay? It doesn't have to be positive. K can be a fraction. But the thing is, it has to be some constant times x, and that is direct variation. We can represent it with an equation, y equals kx. A graph is a line that passes through 0, 0. Notice that this line passes through 0, 0, the origin. Or words, we could say that y varies directly or is directly proportional to x. All right, we're going to jump into the lesson practice. This lesson sounds hard, but it's actually pretty easy. Tell whether each equation is direct variation. If it is, find the constant of variation. Letter A, this is not direct variation. How do I know that? Because it is a y-intercept. If the y-intercept is anything other than 0, it can't be direct variation. It has to pass through the origin. Also, it's not just a constant times a variable. Okay. What about letter B? That one, yes, it is a direct variation. Now, we want to set it so that y is on a side by itself so that we can find the constant of variation. That's the correct way to do it. So we get y equals negative 3x. So the constant of variation is negative 3. Okay, that one was a little tricky. Hey, could your constant of variation ever be a fraction? Could it, like, if it was y equals negative 1/3 x, yes, your constant of variation can be a fraction. Letter C is another tricky one. Let's get y on a side by itself. I'm going to divide both sides by 2x. Y equals 8 over 2x. Now notice that x is in my denominator here. If x is in the denominator on one side of the on the fraction in the fraction, it is not direct variation. It's a different type of variation we're going to learn about later. So x has to be in the numerator. If it's in the denominator of a fraction, it is not direct variation. Let's look at letter D. For letter D, we have 3y equal to x, or y equals 1/3 times x, or x over 3. Yes, this is direct variation, and our constant of variation is 1/3. By the way, I forgot to write it, but this one's not. Okay, let's continue onward. Letter E asks to tell whether the ordered pairs represent direct variation. This is actually quite simple. All we need to do is divide the y value by the x value. And if we always get the same thing when we reduce, it is direct variation. 10 divided by 3 is 10/3. 40 divided by 12, I can divide both of those by 4. That becomes 10/3. 30 divided by 9, each of those divides by 3, 10/3. If I divide y by x and always get the same number, yes, it is direct variation. By the way, my constant of variation is y over x, 10 over 3. Didn't ask for that, but I'm an overachiever, I guess. Let's look at this one. 4 divided by 10 is 2/5. 6 divided by 12 is 1/2. I can already say with the second point, because those are not the same ratios. No, this is not direct variation. And letter G. Write an equation for direct variation that includes the point at 972. What's going to be y equals kx, and k is just going to be my y value divided by my x value. K has to be 72 over 9, which is 8. Y equals 8x. Let's see if that's right. 9 times 8. If I plug in 9 for x, I get 9 times 8, which equals 72. This is the right equation. Letter H. The number of boys in a class varies directly with the number of girls. One class has 6 girls and 18 boys. Well, let's see if we can figure this out. Y equals kx, and k is going to be, let's see, boys varies directly as the number of girls. Let's just go up here and look at this. Y equals kx. Y varies directly with x. Boys varies directly with girls. So boys are y, girls are x. I could do b equals kg as well. But let's just, so boys are y and girls are x. Let's take 18, my y, over 6, my x. 18 over 6 is 3. That's my constant of variation. So the number of boys is 3 times the number of girls. How many boys will be in a class with 8 girls? Well, I'm going to plug in 8 for x. That's y equals 3 times 8 is 24. There we go. Zoom out a little bit there. Y equals 24. All right, letter I. The volume of a box with a fixed base area varies directly with its height. A box with a height of 4 centimeters has a volume of 29 cubic centimeters. Graph this relationship and then use the graph to estimate the volume of a box 3 centimeters tall. All right, so I know that I have an xy of 29 for y, and 4 for x. So this is going to look like this. 29, 4. Y equals 29 over 4 times x. Let's see if this matches expectations. So the volume of a box that's 4 centimeters in height has a volume of 29. Let's see. Does our volume at 4 come out to about 29? Looks like it. So it looks like I've got this correct. Now the question is, what is the volume at 3? I'm going to use a little trick I know, and I am going to create the line x equals 3, and that'll give me the intercept here, 21 point, or the intersect, 21.75. So 21, about 22 uh, centimeters, cubic centimeters is about the volume of the box that's 3 centimeters tall. All right, that's it. Now you are able to work the problems for this lesson.